Hi everyone, I'm Elias Farhan. I'm a video game developer here at Studio Team Quaqua, based in Switzerland. And I wanted to do a little presentation about Game Boy Homebrew Development. If you're like a hobbyist and you want to program a bit for the Game Boy, or if you want to do that in a game jam. So, I'm the co-founder of Team Quaqua with Kevin Peckley. I'm known to do a lot of different game jam all around the world, and here in Switzerland I received the title of Extreme Game Jam Hunter. My spiritual animal is the cat, so you're gonna see a lot of really bad memes in this presentation, and also in my games you're mostly gonna see cats too. For my studies, and a bit where I am professional-wise too, I did a bachelor in computer science here at EPFL in Lausanne. And I did my master in game design at the Zurich University of the Arts. So I'm a bit between the two worlds of game design and programming. And now I'm also the head of the games programming department at the SI Institute in Geneva. So I'm also sharing what I do to my students. So let's go back to the past and watch advertisement for the Game Boy. I guess
oh yeah!
Everybody played it. Still remember all those moments where I was playing also the Game Boy with a lamp in my room and trying to hide from my parents. Now watching this advertisement, I realized it was not so bad. I didn't have television. So, disclaimer before I go on. I'm not a super programmer for the past, meaning I was not programming in the past on the Game Boy. I was not even born when the Game Boy came out, so you can see where I'm coming from. I'm more like the new wave of indie game developer, having fun creating games. So it means you're not gonna see like super clever tips, tricks from the past from here. So we did a Game Boy game for Game Boy Jam. So I just want to introduce it. It's a 10 days game jam, so it's like you have the week and the 2 weekends to do a game. So there's not a themes per se. So you're not starting on Saturday with the theme and then you go on. But there's some constraints, of course. Like you have your resolution for the game is like 160, 144 pixels. You must have 4 colors palette. So it means on the screen you only see 4 colors. It can be any colors. You don't need to do the original Game Boy colors. And you sort of have to have the same inputs than the Game Boy. But it means also that you don't really have to do a Game Boy Game Boy Homebrew per se. It's really hard in 10 days to do a Game Boy game. You can do like a standalone desktop games with the Game Boy in the middle or whatever, and it's working too. That's what we did the first 2 years. So the first game I did was Furbrawl. I did it in Python at the time because I was still programming in Python, and that's the game on the right. And on the left we did like Black Whisker, which was like a hack and slash. I mean a really bad one because like when you were the distance you had for your sword was really small, but there was like really nice narrative ideas that we have for this game, and inspired for the next game we did. So why the hell would I want to do a Game Boy game? Because it's like, it's really challenging. It's you don't have the nice Unity editor or all the nice tools you did. You're sort of starting from scratch. It pushes you out of your comfort zone. So that's something that I was searching at the time when I was doing Game Jam. I was like starting to get bored of doing always like really simple games, and so coming out of my comfort zone was like one of the main motivation I had. Full nostalgia, of course. That was my first console, the Game Boy, the original one. I played Super Mario Land 1, Super Mario Land 2. The Game Boy later I had Mario Land 3. Of course I had the Pokemon games. So yeah, it was really nice thing. And also, last motivation was from Black Whiskers, the game we did before. There was like a really nice universe that came out when we were in Stunfest in Rennes, and we were like discussing with Alexis Simonetta, who's the main artist on this project. I'll put his link portfolio in the description. He's really talented artist. I can't stop bragging about how good it is. And we wanted like to put the universe into practice, because like we were trying some things that was not working so well. So there's a like little to-do list for every programmer. I really hate to learn while I'm doing a game jam, so I'm always trying to like start before to program a bit. Not program the game, but just like know how the hardware and everything is working out. So first we need to learn like how to draw sprites and how to animate them, how to show like a tile background, how to do music, how to do sounds. That's probably the weak point of the games, the sounds. How to use ROM banks. So that's something like the specs of the Game Boy is pretty small, so you can extend the size of your ROM, but it you can see my super arc. It's pretty hard, and this question like, how am I gonna be able to do that in 10 days and probably kill me in the end? That was a really hard experiment, of course, but that's sort of the motivation you sort of need to. I mean, that's the thing you need to prepare yourself before you're entering Game Boy Jam to do a Game Boy game. So the spec of the Game Boy, you have it's an 8-bit system. So all your integer is on 1 byte. The RAM is pretty big for this system. For such a small system, 8 kilobyte of RAM is pretty enough to do. I mean, means you can't have a lot of temporary enemies and all things moving around, but it's still pretty much a lot of space. And 8 kilobyte VRAM, so that's something we don't hear much from now. But the video RAM, it's where you're gonna like draw the sprites, and then they're gonna be drawn on the screen, sort of like temporary memory for all your graphical data. So there's no floating point number on the Game Boy hardware. You can use them, but the thing is they're simulated in software, which means they're not so optimal. There's no multiplication and division for integer. That's the hard point too. I mean, you can always use it, and it's not like gonna drag so much your performance. But if you do that every frame, and you're doing a multiplication every frame, then you're gonna see like the performance drop pretty quickly. You can program in assembly. That's a really special assembly, or you can program in C, which means there's no class, so you don't have mono behaviors and all your really wonderful things like in Unity. For the sounds, you have 4 channels. You have 2 pulse waves, 1 PCM 4 bytes wave sample, like if you want to do actual sounds like the Pokemon sounds and Pokemon Red and Blue, and there's 1 noise generator. The frame rate is 59.7, so it's not like 60 precisely, but I mean, you won't see the difference. And you have 2 bytes color. On the original Game Boy, of course, you have more bytes for I'm not so sure. I think there's still 2 bytes color, and it's like how it's stored in the hardware is a bit funny. I'll talk about it. So it's like 4 shades of gray that is put on like a green screen. So a lot of people, when they're doing like a standalone game, they're like trying to simulate that through a shader. There's no shader, of course, on the Game Boy, so you have to have fun. Of course, I chose the original Game Boy because you don't need to switch palettes like on the Game Boy Color. So the original Game Boy, you just have those 4 color, and you don't have to like worry about switching palettes and all the other pain that you can find. So, quick introduction to the Super 8 universe, where the game that we did is on. So it's a really nice universe that we have with Alexis Simonetta. it is haunting me for years and years, and I'm always like trying to make a really good game in this universe, and that's why we chose it. So the whole world is in a big soup. You have a family around the table with two godly children. So Bruno is like the god of the soup because it's like the benevolent kid who does not want to drink his soup, and Kevin is like the destroyer of worlds. That's like eating his soup before everyone is like saying cheers or whatever. And of course you have like all sort of different animal characters in the universe. Of course you have a cat as the main character. And so you have like the bread that you put in the soup are like islands with a boat from the like 16th, 17th century, even 18th century. So really like pirate settings. You control this lovely cruise on the left with black whiskers, white fur, and crocos, and you're fighting against like the evil bad guy on the right. There is Mr. Whale. So it's like really the cartoon from the 80s and the 90s are huge inspirations. A bit of Miyazaki and all kinds of other things. And we tried to do some gaming in this universe, because that's a bit of the problem when you have like a big setting, something like this, to make it a game. Like the prototypes are never like worth it because you feel you're not good enough. But it's still, we still have project in this universe. It's a bit crazy universe, but it's like at least we're trying. But so when we arrived at the Game Boy Jam, what was a good constraint for us trying to do like really big games in this universe is like, yeah, but we have 10 days and we have like the constraint of doing a Game Boy game. We need like something, a really simple concept. So like platformer is like one of the simplest game genre to like create a game for, but doesn't mean like making good platformers take also a really lot of amount of time. And so like I don't like just do a platformer where you just go move forward. So we did like the original idea was like a dungeon platformer that would be really perfect for the Game Boy also. So we did Soup Raider Jailbreak. You have the link in the description for the itch.io page. So you control Black Whiskers, so like you're this really small cat, and you were captured with white fur, and you're locked in the prison. So jailbreak, you need to get out of this prison. Of course, it's like really simple. That's also something where like we don't like pressure you, the setting of the universe on you. So it's like really small game. You're not like exploring the whole world or whatever. And you take keys, you open doors, and she's been like she wants you to move forward. So the gameplay is pretty simple. You move, you jump. You can jump on enemies to kill them. I mean, there's only one kind of enemies, and you climb wall because you're a cat. You can climb. You can crawl and go through small holes. And of course you can get the keys to open the door. So really minimalistic gameplay, not so much things to learn. I mean, you only have like 2 buttons, and so you can't do a lot of things. And that's how the game looked like at the beginning. And you can already see that in the beginning here we had like I was on my Mac, and I was programming like the level design. I was doing it directly in an array of number, which is not exactly the best way to do it, but I mean it's a game jam, so I was a bit crazy, and it was already working out at the beginning. So now I'm going a bit more in the details. The source code is at this Git repository, but you should be, I mean, it's my second disclaimer. The code is really bad. It's a big chunk of hack that is horrible C programming practices. But for example, if you want to use, it's better with variables to put them in the global scale scope than in the local scope for weird reason used by the compiler, because it puts, like if you have a global that is a variable that is used everywhere, it's put on the ROM and things like this. So it's like really horrible practices, but then it's only me coding that. So, but So the compiler that I was using was a Game Boy Development Kit. I mean, it's a compiler with a lot of different caveats. You can find for modern Linux, I used the repository of Gija, which is like a patch to make the compiler work. It's a really old compiler. For Mac OS X, I'm not sure it's this GitHub repository, but I found a patch somewhere on the internet at the time, and I can't seem to find it again. I hope it's a good one. And on Windows, you're probably gonna have to compile GBADK with MindGV or Cygwin. I mean, GBDK is a really old version of SDCC that is not compilable anymore. So you probably you can maybe use the modern Linux version, try to find something. But yeah, it's like a really old compiler. I mean, Game Boy Homebrew is from a long time ago, and I guess you realize because I'm using a compiler, most of my code is in C too. So for the movements, I can show you the little video here, but when we're using like Box2Ds or other physics engine, we used to like use meters. Now we're on the Game Boy, so it's not like the best idea. So you're moving 1 pixel per frame, you're jumping at 3 pixels, something that is really simple. But the thing is, now when you're jumping, there's a little problem, because if you did your physics, you have the movement equation that is pretty like stored in your brain, which is like minus 1/2 of GD square plus V0 t plus y0, for example. That would be the typical equation. The thing is, now you're on the Game Boy, so you remove all your 1/2, your whole multiplication, thing like this, and you have to think a bit more subtly. So it's like you have to use a linear equation if you want to use that, and like the best way to use that is to control the velocity instead of the just the position. So you like control the velocity, and every frame you apply the linear velocity, and it works because it's like 60 frames per second. And so what I do is, like, when you jump, you have 3 pixel per frame of velocity, and every 5 frames, I remove 1 pixel per frames to this velocity value, and that makes physics works properly. So it's like little tricks like this that makes Game Boy development pretty fun, because then you're like confronted with really subtle problem. Like you can try to do minus 1/2 GT square and do multiplication with floating point number, but it's really not the good idea. You can of course crawl into other sides, more like a cinematic where I would just move the character, so it's not something so crazy. And the climb tool, then it's pretty funny, and there's a little thing with this, because like if you climb walls, then you have to differentiate which box you can climb or not, and the decision I took is like every physical box is climbable, so it means the boxes you have at the beginning of the game you can also climb, which is a bit funny. So box physics, I mean everything is box, so I use boxed everywhere, boxes. The thing is, how I like divided this level is like you only have one panel level at the time, every screen. So when you move to a new panel, then you have a new scene where I start the physics over again, and all the characters, the enemies, the locks have a physics box around them. And of course, if you go against the wall, it pushes you back. If you come vertically, it's like pushing you back up too. I mean, you can see here in this when I'm jumping, I'm going inside the. You can see I'm going inside the tiles, which is pretty funny. So I needed to correct that, of course. But the thing is, because I did that, the physics of the next slide, because I did that in 10 days, there's like little bugs, some that I left, but some that I did not foresee. where depending on the configuration of the boxes and how you jump into them, a bit like in Mega Man, it can push you on the wrong side of the box. I can show you quickly. Let me check my settings. Stream capture, yes. So if I run the old game version, that's the complete wrong screen though. Here. So here, for example, what I was saying, here there's a box, for example, that does not allow you to move forward. You can climb on it, which is a dumb bug. And the thing is with the physics, here the priority means that you can also like do crazy shit and go through. I left this bug, I left it intentionally, so I knew about it, don't worry. Nope, let me remove that. So, physics with boxes, like what I did is like, if your character is entering 1 pixel inside of a box, it push back. If you're walking, if you're jumping, I think it's like a bit more complex, and if like you come, it push you back or up, depending on the half size of the box. I corrected that in the new version of the game that I did not release because I'm still working on it. But it's like little bugs like this. So bugs like this, box physics. How I was doing level design is like really sad. So I can show you. I mean, I showed you already on Eclipse. So I showed you at the beginning, and that's how I did. So like 6. I think the number between 1 to 6 are like tiles for the platforms or the wall. The background, it's from 11 to 16. I know it's to 18. Like for example, that's actually I can show you with the emulator next to it, because that's the first panel, the first. So here you have like, you can see the numbers here, 666664, like 6664 here with a different tile here, the wall like this. You can see that there's no mention of the characters, of the lock. The lock is a special object that's put directly in the code, really smart. And so you can see in the background here when you have the windows, it's like other numbers like 15, 17, 16, 18. And when you have poster, for example, here, this poster here, so that's the level 2, it's other numbers here. You see, it's from 19 to 34. There's other posters that are added in other part of the game. So, of course, it's a really bad idea to do level design like this, especially because, I mean, the logic behind it is like there's 10 days, so there's not a super big motivation to like do a level editor or something like this, and at the end the game is just a binary, so your level design has to be in the binary in a way. So you can like write it by hand in C, or you can like generate it. That's what I did in the next slide. And you put numbers in array, which is really painful, because if I show back on Eclipse what's happening, the boxes, physics of boxes are here, and it's like bottom left position and width and height. For the size of the box, and if you do any mistake here, you have like to test it, check where your physics is supposed to be, change the value here. So it's a really long process that is like really painful. But now that I know the logic of the game, what I did is I created new tools, and I used tiled map editor, so you can see like the new version here. I can make it a bit bigger, so you have the same level here, And also I can use also objects to create boxes and locks. I pretty should do like categories here, but so it means now that everything is sort of generated, and then you can compile it. So that's the version after the jam version, and it means that all those value here for the tile and everything are also generated. So now I can like extend pretty quickly the level. Then I still need to like hack a bit some things, like it's from tiled map editor to the Eclipse version. There's still some things that I need to change values, but it's like way better than using directly to change the value in the iris. So the thing is, I can't just use tile map editor and do like import maps from my super awesome games. I needed to do what all the tool programmer are doing, is like converting the values, converting the image to the good format. So the sprites, I'm going to talk a bit more later, they're binaries. The program that the artist is using is not exporting PNGs or a JPEG or a BMP. It's all binary of 2-bit value for each pixel. So I needed to convert that into PNG. So I did a really like smart program for that. I can show it quickly. And I need to use Python 3. Put that here, put the window down there. It's up like this. So here this little program that is called like GBDev tool window. I can open the Game Boy Tile Designer and toolkit, which is our program, but here I have a list of different images that are generated by the by Game Boy Tile Designer, which is the program the artist is using to have like Game Boy assets. And I just use the raw bin, and what I did is like a super tool where I want to convert it to 8, 16, 16, 30, 30 images, depending of what I need in tile map. So then I can have directly the assets here correctly written, and I mean the one that are interesting for tiled is the background here, the posters, and this one here. But I still did it for the rest in case I want to just place the enemy, and then I can also use it in the game. So then I have tile map, so it looks like this. I place the different tile I want. I used directly the value here for the environment, so you can just I just could put the tile here and it works. For the background, it's the same. I just put 4 and I just filled it and put the window where I want them. The poster exactly works the same way. And the thing is, then at the end, the tile map editor is gonna like export to JSON, and then I needed to do a really clever program, again a conversion tool, and that's where there's still a bit of improvement. So I'm converting the levels, and now if I show you in Eclipse what is shown, so that's the old jam version, and in the new version I can show you the levels here. Well, I commented the levels and the boxes too. So here now in the data I have the level maps here. And well, that's generated, so it's not me who is moving those values. It's counting the number of boxes that are in this particular area and putting the value automatically. It puts the logs too. So now I have the value for the box, the logs, and I separated that's the new old value. It's the new value. I'm not sure exactly, but it's like a constant. Box value, box logs, whatever. Okay, but then you have the logs, and that's still compiled properly and used in the and the level. The thing is, I still need to like program the logic for each level separately. Like if on this level I'm touching this door while I'm jumping, then I'm going to the level 3 and other logic like this. Of course, I needed also to switch the logic of the little panels. Like when I did the jam, this was panel 1, this was panel 2, this was panel 3, 4, 5, 6, which is a really dumb way to do it because it's not coherent, and I needed to switch, so I did. Now it's 1, 2, 3, 4, 5, 6, which is like Z order, typical way to do that. I could have picked another one, it's just convenience, because when you're using tool, then you have to be coherent between your different panels. So that was for the new level editor that I'm using. Tiled map is pretty good. We still need to find some ways. Like I still had some problems when I wanted to do something specifically and it was not working, but it's hugely better than using level design by hand. So sprite versus background. Sprite, they can be moved. You can only have 40 sprites maximum on the screen and 10 per line. That's a hard requirement. If you try to do more, some sprites are gonna disappear. And the background is sort of set in stone. So it means like when you're loading a panel or the background is set in stone and you don't touch it until you switch to a new panel, a new level. And you set them in a tile map, like binary data, and the order is like sprite, background. I think there's one more. I think there's like a special kind of. I think it's like environment tile map that you can put also, but we didn't use that. All those assets are they're written with game GBTD, which is Game Boy Tile Designer. I can quickly show you how it works. Here, just need to move all the windows, and here set up that. So it works like this. You put the you can put here the color like this, and that's it. And if you want bigger view, you can like put also 16 to 16 if you want to do like a big character. I don't know how to draw, I'm not the artist, but then you can put the different values like this. Good old pixel art. That's pretty easy software to use. There's not like really complex things, and at the end you export everything to C if you want for GBDK. I did something a bit special. I put it in assemblies, and then you can like it's a little bit more optimal to use assembly, but then you don't lose that much data. So yeah, that's Game Boy toolkit, Tile Designer. And it works on Wine for Mac and Linux. So I was mostly on Linux and Mac OS X. The artist was just using Game Boy Tile Designer, sending me the project file, and I was doing the export and making it work on the game. For big images, you can use Game Boy Toolkit, but then your game is gonna lag a lot. If I show back again the title screen, or even like the first screen of the game, I know it's lagging because I heard the music when it was like at full speed, and this is like twice. It's like half the speed it's supposed to be, but like nobody's realizing it because I never heard the original music. So I'm like, I'm safe. But then it's like dragging on the battery of your Game Boy if you leave it like this. But yeah, the problem is the background of the Game Boy, you can't like feel the whole screen. You're limited by 255 tile. The thing is, if you do your multiplication, if you have 20 tiles with an 80 tile height, you have more than 455. It's the, if you do the calculus, it's good old Python. You have 20 tiles and you multiply them by the 80 tiles height, you have 360 tiles. So it means like what it's doing is like on the first frame showing the first part, second frame showing the rest of it. So that's a nice trick, but it's really, really bad. So, so big images can be like, you just use your BMP, you have the Game Boy binary format, but yeah, put that in another ROM bank because, and that's the thing I'm going to talk about just after. Well, the whole code, your whole images are all stored in the main ROM, and you can use ROM banks to like put data that you're not like really needing in the main bank. So the main bank and the main ROM is 32 kilobytes. You always have access to this ROM bank, and you can use other ROM banks to extend your game to 8 megabytes. I think Pokemon is like 1 to 2 megabytes total, the ROM. The thing is, so you can only access the main ROM memory and one other ROM at the time, and you have to switch it manually in your code. So that's a big source of bugs, more than just the pointers in C that are always like a pain. And so that can be a big problem, because if you're like trying to access data that are in another memory bank, then it's blank, there's nothing, because like when it's trying to read, it's like null, the values, and if you're like really depending on it, you can just crash your game. And of course, when it crash, I mean, for all those who did C or C++ code, you break things along, you segfault. When you're on Linux, you use GBD, GNU debugger to see where in your game the bug occurred. When you're on Visual Studio, it's showing you nicely in the editor, yeah, your bug is here. Maybe you should put like a value in this pointer instead of accessing memory you should not access. But the thing is, when you're writing for Game Boy, when you crash the game, it's just a blank screen, or it's just the screen and it's nothing is working. So the thing is, you have no idea where the crash occurred, and that's the moment then you have to be like paranoid with your own code and your own self of the past. And when you're in the game jam context, this can be like really a pain. And I sort of invented a term for those kind of moments. It's called cat programming. So instead of being like really intelligent, you do something really dumb, which is like changing the value that you think is not working, check if it's working. If it's not working, you change maybe another value, and then you change back, and then you change something else, and then it's working, and you don't change anything. Everything is working. I'm never going to touch this value again, even if it's really stupid or if it's not doing anything. So it's like cat programming, because like with the pose, you're like changing values and check if the program is going to work. So it's a really dumb way of working, but it's like sometimes you have to resort of those kind of horrible tricks to make anything work on the Game Boy. For the music, it's pretty easier than with Bright or anything else. It's just you use the tracker. So a tracker is a program where you put the notes of your music. You use 4 channels, and then there's a little script that is given also in the game dev repository, which is really good, which converts to the mod file to a GB format. And then in your code you use a GBT player, which is known as the yellow tracker player, something like this, to play the music in the background. That's working pretty great. You use another bank, and probably your music, you need to put it in another bank too. But the music is taking way less space than an image, so it's really good. And for sounds, so it's a bit weird. So you can use .wave, but the thing is, if you use a .wave, you're freezing the whole game. You're using the whole capacity of of your Game Boy. And actually, there's an example of that in Pokemon Red and Blue, when there's like the Pokemon sounds when you start a fight, or when you're looking on your Pokédex and you do like the noise of the character. Your actual Game Boy is freezing when you do that, because you can't Skype stop the sound or thing like this. Which is a really clever tricks, but if you like want your character to jump, or you're hit by something, you might not want to use a dot wave, because then the whole sound is going to play and freeze your console. But you can use other things. I'm still not sure how it's working though, but I can at least show you. I mean, I looked at other homebrew games where they did, like for example, there's the explosion, there's a pew pew pew. I mean, that's literally copy paste. But then I just changed the value of the playtime. Then there's like the value, I have no idea. I just changed them to try something different, and so you can hear the sound sometimes. The thing is, when you're using a sound, you're cutting one channel to the music, so that's the kind of thing you also have to be aware of. And yes, that's sort of how I did the sound, but because I didn't have that much time, I still don't know how to use the sounds correctly in the Game Boy. But it's probably like, you can probably change like the frequency, how it's like noise generator. I probably have to learn it if I want to extend the game properly and have proper sound. So yeah, it's like really bad practice for the sounds, but it's like sort of working. It was not the most important thing for the game. So in short, if you want to really develop for the game, you really need like to fully master it before you attempt anything else. And if you want to jam on it, really take the time beforehand to implement things that you will have to do during the jam, like showing sprites, applying sounds, playing musics. And for every feature you're using, it's a bit like online multiplayer when you're doing a multiplayer game. Every feature you can multiply by 10 the time it's gonna take. That's for sure. If you want like an easier alternative, there's the Harder Boy, and it's actual C++. You have less RAM than the Game Boy. You only have 2 kilobytes, and there's already 1.2 kilobyte used by the system. So you're using only like 0.8 kilobyte. For the Game Boy, it's like 4 kilobytes. So like the Game Boy is a bit easier in terms of RAM. But the thing is, then the Game Boy, if you really want to use the whole 4 kilobytes at the max, you probably gonna need to use assembly instead of C. C is adding a lot of other overhead on the code. You have 32 kilobytes of ROM, a bit again like the Game Boy main ROM memory, but the thing is, well, you don't have more memory for the Harder Boy. And this 12 kilobyte is used by the system, so at the end you only have 20 kilobytes. The images are way smaller because it's just 1 byte color. If it's 0, it's black. If it's 1, it's white. And there's really nice games that's been done by the Team ARG. I'm not sure again, but I put the link and there's the description. An Harder Boy is like $40 Swiss francs, 40 euro, sort of. You can find them on Amazon, or there's like special retailers too. And it's really nice. You can like plug and install. Like there's no cartridges, so you need like to put the game through USB cable, but it's like pretty simple. So yeah, I just want to thank all the different organization in Switzerland that's helping me doing crazy games and motivating me too. And that's it for my talk. Thank you for listening, and have a nice hashtag, not GDC. If you are interested to read more about me or follow the crazy things I do, you can just like add me on Twitter. There's my blog too. You can mail me at my mail address, and I'll put all the different links below if you're interested more for Game Boy development and things like this. Thank you very much.